Hi everyone, I hope this finds you doing well. I wanted to show a demo of the latest enhancement to Illuminated Cloud. It's a first-class integration of Salesforce Code Analyzer 5. Now, I've actually had quite a few requests in the past to integrate Salesforce Code Analyzer in its earlier iterations, 4 and before. And my general response to that, and I'll actually talk more about this throughout the demo, is that there is a tremendous amount of overlap between the information that is available from Salesforce Code Analyzer by virtue of the engines that it actually effectively proxies, PMD, ESLint, things like that, and first-class static code analysis capabilities of the JetBrains IDE and of the Illuminated Cloud plugin for the JetBrains IDE. Things like PMD, that is an engine that is supported by Salesforce Code Analyzer, is already available in a first-class manner in Illuminated Cloud's PMD Salesforce real-time inspection. Similarly, ESLint is already available in a commercial JetBrains IDE in a first-class manner, and in a Community Edition IDE by not exactly the same, but very similar by virtue of LSP for IJ and the TypeScript language server if you're using those. CPD, the copy-paste detector that helps you enforce the dry, don't repeat yourself principle, is also available as the duplicate code fragment code inspection. When I looked at it, and even the Salesforce Graph Engine, a lot of the things that it presented are first-class code inspections that Illuminated Cloud already has for Apex. When I looked at it for earlier versions, there just was a very small gap for what was a potentially large amount of effort. Having said that, Salesforce Code Analyzer 5 actually integrates more engines, is going to continue to integrate more engines. There are more on the horizon, adds some neat, compelling new features like Agentforce for developers / generative AI based quick fixes, which vary in quality. Again, I'm going to show those in this demo. But these new enhancements, these new kind of expanded engine support capabilities, things like that, prompted me to revisit my decision to integrate this. And obviously, by virtue of the fact that I'm about to demonstrate it, I decided to integrate it. And so like other static code analysis capabilities, it's implemented as a code inspection. Now, there's going to be a difference though. Other code inspections, if you're used to them, they are evaluating constantly in real time. So as you're making changes in an editor, they're actually evaluating the work in progress document. You don't have to save to disk. They generally provide results in small numbers of milliseconds, whereas Salesforce Code Analyzer is implemented as a Salesforce CLI command. SF code-analyzer run, and then some args, and it itself, again, it's a facade on top of a bunch of other static code analyzers, so like 6 or 7 of them now. And while it runs them in parallel and only runs the ones that apply to a given file, you are talking about multiple seconds to get information for a single file versus milliseconds, and it does need the contents of the file to be persisted to disk versus being able to operate on the work in progress. So there's going to be a difference here. I'm going to talk about the considerations around those differences and ways to optimize for it in the process of this demo, but I want to kind of say that up front. Now, having said that, why don't we go ahead and take a look at getting like a bulk run on it, and then later we'll look at, and I'm air quoting here, near real-time results integration into the editor. We'll come back and look at the configuration capabilities of this inspection after we do those. So I'm going to go over here and I'm going to go to Code, Analyze Code, Run Inspection by Name, and we'll use Salesforce Code Analyzer to just run this one inspection. And of course, this is one of the wonderful things. You can choose any scope you want. You can, in fact, create your own custom scopes. Just run on Apex or just run on Lightning Web Components, whatever. I'm going to run on the whole project. The same configuration we saw, we're going to revisit that. And I'm going to go ahead and just let it go. And you can see down here that it is running. It's actually running that Salesforce CLI command. That CLI command is going to end up outputting a normalized report across all of the supported code, static code analysis engines. And Illuminated Cloud is going to adapt those results into its own format. And so we can see that we got 124 error level violations, we got 185 warning level violations, and 614 weak warning level violations. Now, Salesforce Code Analyzer, again, it normalizes the output and normalizes violation severity levels to 5 different levels. SEV 5 is kind of the lowest level. It's going to be information level. SEV 1 is the highest level. It's going to be kind of a critical level. In between, you've got like weak warning, warning, and error, I believe. And Illuminated Cloud translates those into the IDE's corresponding levels for any other thing that reports violations. And so let's just take a look at some of the actual violations we got. So this is the Apex Recipes Salesforce kind of reference project. I want you to get used to this particular message format. It is configurable, but this is going to help you very quickly identify things coming from Code Analyzer as opposed to coming from some other first-class mechanism. So the default is going to be the engine name, PMD, the rule name, avoid debug statements, the reported severity, severity 4, which is that weak warning level, and then the message, avoid debug statements and say impact on performance, but the actual message. And then the thing that you don't see here, but you can see over here, would be the affected text range, the violating infraction text range. So that's something you don't see reflected here, but you see it reflected in the actual editor. So we can see another file, and we can see that we have some more stuff from PMD. We're in Apex, that's not surprising. So we have another sev4, queuable without a finalizer, another sev4. So again, these are kind of low level. A non-restrictive SOQL query, so nothing filtering, nothing limiting results. If we scroll down, we can see something maybe a little bit more interesting. So here's one that actually has some errors. So sev3, sev4, now here we have a sev2. So your typical CRUD FLS, you're missing CRUD FLS checks before you actually do the corresponding query or DML. So in this case, we're doing DML, and we didn't actually check to see if the current user can do that. And if we're obviously, that's because of the way Salesforce works, that could be allowed when it's not allowed. So especially if you're doing, security review or something like that, you would want to actually act upon these. Let's scroll down and look at something other than Apex. So here's a flow, so some declarative, and a different engine, regex. Avoid old Salesforce API version. Sev2, this one's higher, so this one's more of an error level type of thing. Versus critical, and it's basically saying that there are security implications and maintenance implications to using API versions that are more than 3 years old. So in this case, it's kind of setting a threshold saying that 55 is the earliest that it wants to see. 54 and before it doesn't want to see, and this is 51. So that's an example of where it found it. And because it's regex, it's just doing pattern recognition, looking for API version paired tags in XML files. Let's take a look at Lightning Web Components JavaScript. So here we have a third engine coming into play from Salesforce Code Analyzer. It's ESLint, and it's saying various things. One of them here is saying don't use old school var kind of leaky scoping. Instead, use new school letter const. And so, it's kind of guiding you towards just best practices there, and some other things here. And you would see things in other files as well. So the reality is we're talking about roughly 1,000 different violations up here. Yeah, you can make a good pass and get a good baseline. You're going to adjust your configuration file and your various severity levels and which rules and engines are enabled, things like that. You're going to get that down. You're actually going to fix some things. But on a day-to-day basis, you're not going to be looking at this. You're going to be looking at a file level view of the world. You're going to be, and really not even here, you're going to be looking at it in the editor, but I'm using this for reference in this demo. But day to day, hour to hour, you're actually going to be using this as real time, quote unquote near real time information, both guidance, directional guidance, and also letting you know about true honest to goodness problems so you can fix them before they become a problem. And so let's take a look at the information that's conveyed here for this file. You're used now to this particular format, and you can see that not all the entries in here are of that format. So some of these are from Salesforce Code Analyzer, some of them are from other static code analysis capabilities. In this case, we see that this is Illuminated Cloud's Apex doc validation, saying that we have a public level method in here and it doesn't have an Apex doc comment because I've configured that code inspection to say anything protected or higher, part of kind of a public API, should have a documentation comment. Then we have something down here from Illuminated Cloud's first class integration of PMD Salesforce, saying we have an injection vulnerability on line 13. We have some more Apex doc stuff. We actually have a false positive here. It's worth pointing this out because static code analyzers aren't perfect, saying that we have an unused variable. PMD is saying it has an unused variable. One thing I'll say about PMD is generally it only knows about its own file when it analyzes a file. There are ways that you can look at other files, but it doesn't have any kind of like relational or referential information, like for example Illuminated Cloud does with its unused declaration inspection. So it also in this case isn't even looking in this file at this usage, which is not in Apex, it is in a dynamic SOQL query as a bind variable. The point is this is a false positive. I need to report this to PMD. But things like unused declarations can be a little bit problematic with something like PMD, and it's one of the reasons you don't see things here with Illuminated Cloud's first class PMD Salesforce integration. You don't see this being reported because it has its own configuration option to say don't report on things that Illuminated Cloud or the JetBrains ID already does and does better, in this case unused declarations. suppressions. We'll look at how we can do the exact same thing with this Salesforce Code Analyzer code inspection. But this is a false positive. If you took out that line of code thinking that, just kind of, in fact, I think if you take a quick fix on this, it would take out that line of code and you would have a problem because you would basically have an unresolvable bind variable. You also have things being reported down here by the JetBrains ID. In this case, just typos. We'll see more being reported in a different file. But for a moment, let's take a look at some of the duplication here. I started by saying that I didn't integrate the static code analyzer previously because there was a huge intersection between what the JetBrains ID and Illuminated Cloud can already do and what Salesforce Code Analyzer's supported engines do. And we're already seeing that here. So this Apex dot comment that's missing on line 11 is also reported by Salesforce Code Analyzer via PMD. This PMD reported injection vulnerability is also being reported by Salesforce Code Analyzer's PMD engine. A lot of these others are also overlapping. So we'll look at how we can deal with that. Let's move on from Apex again into a different file, a different format of file. In this case, JavaScript in a Lightning Web Component. Same one we looked at earlier. And so here again, we see a mix of sources for a static code analysis overview. So we see a couple from Salesforce Code Analyzer. We see several from the JetBrains IDE's own first-class TypeScript support. If you were in a Community Edition IDE and using LSP for IJ in the TypeScript language server, you'd probably see most of this as well coming from the TypeScript language server because it already incorporates a lot of static code analysis capabilities. It might not perfectly overlap with ESLint, but you would see a lot of the same things. But we also see overlap. Line 64, use letter const instead of var. Line 64, use letter const instead of var. So we're already seeing some overlap here. Let's look at yet another file format, flow, declarative. We see two different things here. Now this is an instance where they're telling you two different things. There's a relationship, but they aren't the exact same thing. They're not redundant. The first one is coming from Illuminated Cloud's inconsistent API version inspection, and it's basically saying we have set a reference point against which we want to align in terms of API version. We want to align at 62.0. That reference point can be your configured connection. It can be sfdx project.json. It can be package.xml. But the point is if it finds metadata files or other references that don't align with that, it reports them. The other one is saying something different. As we saw earlier, it's saying you have a potential security or maintenance issue in that you've got an API, something running in an API version that is pretty darn old. In this case, over 3 years old. So it would be good to align it. But this one's kind of setting a threshold at 55. This one's saying 62. So fixing this one would fix this one, but not vice versa. So again, there's a relationship, but they are not conveying the same information and the same concerns. So when they are conveying the same information, same concerns, what can we do to improve that situation? Well, I alluded earlier to the fact that PMD Salesforce includes an option to filter out redundant rules, and in fact so does Salesforce Code Analyzer. But before we go to that, let's look at some of the other configuration options since we skipped over that earlier. Well, one of them is going to be the configuration file. Now you're not required to have one. By default there's not one there. You can generate one very easily. I'm going to click here and it'll take us to documentation using this command line, and it will generate a YAML file. Now to be clear, this is not the one config file to rule them all. This is an override file, kind of a perimeter level override file for Salesforce Code Analyzer, but you still want to make sure that you take this file and specify, say, the PMD rule set file that you use for PMD elsewhere, the ESLint RC file that you use for ESLint elsewhere. So you'll want to do that to make sure you're using a consistent set of rules across the engines that support, configuration. The YAML file here is then primarily for doing small overrides like severity level, tagging with some taxonomic information via tags. We'll show those later, things like that. So if you don't specify one, it'll run with the defaults. If you do specify one, I highly recommend doing that and getting it configured so that you're using the right rules. Then you can do some incremental overrides. The next one is minimum rule severity. This isn't about when the engine runs, what will Salesforce Code Analyzer and its underlying engines report at. It's about, of the reported violations, which ones will be integrated into the IDE. And so by default, it's going to be report everything. But we can go ahead and change this to like Sev2 and say, okay, we'll come back in. And we'll see this change dynamically so that we only see Sev2 here. And if I go back over and change it to Sev3, we'll see that it will filter and we'll see Sev2 and Sev3. Now, you notice notice this is refreshing pretty quickly, and you may have also noticed that there's nothing going on in the status bar saying it's rerun. That's because changing what we're using to filter is not changing. If we already have cached information, all we have to do is apply this filter to the cached information. But the parameters that determine how Salesforce Code Analyzer runs, which are going to be the config file and the config file's contents, and whether or not we're applying redundant rules, unless you change those, the cache is still considered, or change the contents of a file, the cache is still considered valid, so it doesn't have to read through. So just changing the information that's presented, for example, here, we'll turn off everything on these rules that's presented on the messages. You can see now these look like all the other messages. You can't really clearly understand that those are coming from Salesforce Code Analyzer. We could turn on just the engine and the rule name, and those are coming right back without having to re-execute. And we can, by the way, infer the severity from the icon that's used and by the way that the information is annotated in the editor. So if you're familiar with the way the various levels are decorated here and here, you don't necessarily have to keep the severity on. It is on by default, mainly because I find it useful to just see it at a glance. You can also turn on rule tags. This is that kind of classification information that I mentioned. I find these to be kind of noisy here. If you were using them to kind of slice and dice this information, that would be one thing, but we're not here. So I find them to be a bit noisy. So you can turn those on and off. So those are some of the configuration options. One other I'll mention is when Salesforce Code Analyzer runs for near real-time evaluation, you'll see by default a progress indicator in the status bar, and that lets you know when it's running and when you actually have all the information you're going to have in the editor, because everything else is real-time. If that bothers you, you can turn that off and you won't see it. It's on by default. It's up to you. You can turn it off if you want, but we'll go ahead and kind of change this back for a moment. The other option we want to look at, though, is ignore redundant rules. Now that is going to require a re-execution, so I'm going to say OK, and we're going to see down here it's going to re-execute this, and when that finishes, and now you can see the near real time is a single file, and it's re-executed, and we can see that we get a more focused view here. So for one thing, we don't see any Salesforce Code Analyzer entries here. That doesn't mean we wouldn't. It just means that all the ones that were being reported for this file were from PMD, and PMD is considered a redundant engine because we have a first class PMD static code analyzer. If we went back in here and we actually turn that off, it will see that that is no longer redundant, and will actually show that. But for the main part, we're going to go ahead and just keep that on. All right, so we are showing the stuff from PMD here. We're showing the stuff from the JetBrains IDE. And we have the same information. We have that injection vulnerability. We have that missing Apex doc comment, those other Apex doc things. So we're not necessarily losing any information. We'll look at that again at kind of a bulk level, a batch level in just a moment. Let's move over to our JavaScript file, and we've got to re-execute. What we have is stale, so Illuminated Cloud is going to automatically re-execute that. And so again, the duplicates go away. We still have that use letter const instead of var, things like that, but we don't necessarily see things that are duplicate, and we're seeing things in real time rather than having to wait for the CLI to execute. Let's go to the flow file. Now on this one, these are distinct from one another. So we're going to continue to see both of them when it drops out, because one is, like I said, they have a relationship, but one is not basically a redundant version of the other. So that's the way you can kind of filter this. Let's look at it at a batch level. Let's go back over and say analyze code, run inspection by name, Salesforce Code Analyzer. We're going to run it again, but now we have ignore redundant rules on. Otherwise, our configuration, I kind of reverted things as I went along. It's going to be the same configuration we ran with before, and that produced about 1,000 entries. And so this should come back quicker. It came back quicker because that's the other thing that's happening. It's not just filtering out redundant engines. Illuminated Cloud is actually creating a copy. If you have a config file, YAML file, it's creating a copy of it and disabling things that it would ignore anything coming from it. And so instead of having to run, say, 7 engines, it's now running 4 engines. And of those 4 engines, because we have PMD and ESLint here locally, 2 of the heaviest weight engines are no longer running. So you're going to get faster results. It's still going to be seconds, but hopefully it's like 2 seconds instead of 5 seconds or something like that. But one thing you'll notice here is instead of about 1,000 violations, we have 7. So we certainly lost some information. And that the whole point was, if we do this, we don't lose information. But we only ran one inspection, Salesforce Code Analyzer. And the whole point is it's other inspections, other static code analysis capabilities that are complementary to this and provide that full picture. So let's look at how we get the full picture. So we can say inspect the whole project using I cloned the bundled code inspection and configured it with rule sets and config files and all that. So we're going to go ahead and just run that across the whole project. And you'll see that the first thing it's going to do is run the static code analyzer, the Salesforce Code Analyzer, and then it's going to start running all these real-time inspections. And what we're going to see is we're going to get a whole lot of information, including Salesforce Code Analyzer. But as it finishes, we should see PMD. And if we go up here to JavaScript and TypeScript, under code quality tools, we're going to see ESLint, and under other ones, we're going to see other rules that basically are duplicates, redundant. And so all the same information is there. So for a good example, this would be under PMD, we see those CRUD violations, CRUD FLS. Here we see that injection vulnerability under Apex Doc validation. If we go to data recipes and we go to dynamic sockle, we can see that missing public visibility method documentation comment. So we didn't lose anything. We're just getting it from real-time code inspections that can run faster, that can run without having to save the file to disk, things like that. So that's a way that you can optimize this. Okay, so hopefully that all makes sense. Let's go look at quick fixes, available quick fixes. So let's go back over here, and I'm actually going to reconfigure the inspection. I actually want to, on Salesforce Code Analyzer, I want to disable ignore redundant rules, because some of the things I want to show are based on some redundant rules and what some of these quick fixes are. So as soon as this finishes, we'll see, little squiggly underline. It's squiggly underline in this case is coming from Salesforce Code Analyzer, and the yellow background is coming from the Apex Doc validation inspection, just because, again, duplicate. So let's bring up context actions, and we can see several options. We're going to skip the first one. I alluded to this right at the beginning, basically generative AI based quick fixes. We're going to come back to that because that's just its own subtopic. Let's look at other things. So if the engine rule combination returned a online documentation URL, not all do, but for PMD you get them, then you can view that documentation online. So here's a PMD Apex Doc. If we have a YAML configuration file and we want to see the section that corresponds to this engine rule combination, we can do that, and Illuminated Cloud will take you directly to that. If we wanted to change the severity level, report at a different severity level, Illuminated Cloud will go over and begin automatically editing that, save it, and we'll restart static code analysis, because now we've changed the configuration, and we should see this, instead of the kind of grayed out underline, we should this, now it's red, because we said it's critical. It's a SEV 1. If we want to suppress, we can suppress. This is a PMD Apex only mechanism. You will only see it there, but we can suppress two different ways. We can suppress using a suppress annotations and suppress annotation, or a end of line comment, no PMD comment. And so suppress warnings annotation, coming back to that. So you can suppress using an annotation at multiple different levels. So you can do it at the current declaration, which is a method. You can do it at the declaration's parent declaration, in this case class. If it were a method in an inner class in a top level class, then you would have that option as well. And the containment applies. So if you do it at the class level, it's going to be everything in that class and the class itself. So we'll go ahead and add the annotation at the method level. Notice that doesn't go away immediately, but we are executing the static code analyzer. As soon as it gets done, you'll see this red underline go away. It just did as I was saying that, because now PMD, the PMD engine, sees this as being suppressed. If we save it, we could do it with a comment instead. I'll go ahead and do that real quick, even though each cycle kind of takes a second. So again, near real time, not real time. So it's running this, and then we'll see the little squiggly come back up, and we'll just say we'll do this with an in the line comment, no PMD, it's already saved, it's re-executing, and we'll see that red squiggly go away. So the point is you have several different ways to get more information about the rule that resulted, the engine rule that resulted in this particular violation, and to suppress it if appropriate. All right, so I'm going to undo that. Control Z, Command Z will actually do an undo. That's always added to the buffer. So you can back out from whatever it is that you did. When this comes back up, we'll start looking at this new topic of Agentforce for Developers Generative AI based quick fixes. Now, If you've played with generative AI, whether it's Agentforce for developers or Copilot or whatever it happens to be in terms of a code generation, you know, well, not just code generation, generative AI, you know that it is non-deterministic. You can ask the exact same prompt multiple times with all the same qualifications, and you're not guaranteed to get the same response. You're not even guaranteed to get a response consistently. And that's going to apply here. You may get a response. You may get a different response than you got the last time. You may get a response that's valid code and exactly what you wanted. You may get something that breaks your code. Whenever you do this, it goes to the undo buffer. You can just press Control Z or Command Z and undo it. Don't worry, you're not going to get in a bad state. Having said that, I'm sure you've read horror stories about people who don't use version control or any type of checkpointing mechanism, and they ask some generative AI to go make a change, and it wipes out everything. Everything's constrained to a very small context here. I'm going to go ahead and run this, fixing with Agentforce for developers. But you can always undo. See, just did an undo. I'm going to do a redo. But so this generated a nice header comment for us, right? It generated a nice header comment for us. Let's undo that and let's go ahead and save. By the way, again, there was a little blue indicator up here showing that it needed to re-execute because it was unsaved. That's why you didn't see it execute immediately. Again, it has to have persisted contents. But once it re-executes, we'll do it again and see if we get the same result. Fixing with Agentforce for developers, pretty close. I can't look at a glance and see if that's the exact same result. And because it did that, now it's re-executing this. Let's see where we are. Okay, so we still have an issue. Apex doc is still being reported as sev1, but we're missing at description, that tag, and it didn't add it. The generative AI didn't add it. Let's see if we do this again. Fix with Agentforce for developers. We'll add it. I've never seen it add it. What I've seen it do is exactly that. It changes the text. It is doing a good job of trying to summarize what's going on here. That's something that generative AI does really well, but it still hasn't solved our problem. Well, this is one of those places that if you were saying ignore redundant rules, then Illuminated Cloud's own Apex Doc validation inspection would be here, and it would take into account whether you wanted at description and all that. It wouldn't do the generative documentation here, so it wouldn't give you kind of that summary. There's a trade-off either way. Let's look at another one. Here we have our injection vulnerability fixed with Agentforce for developers. I've seen it get this one right almost every time, and it did this time. And so it saved. It is re-executing down here. In just a second, that squiggly underline will go away and we'll be clean here. I've also seen it use a Java escape mechanism here because it was evidently trained, at least in part, on Java, which is very similar to Apex, which resulted in invalid code. Again, you need to make sure that what it's doing is what you want, is valid, all that. Let's look at, again, a different language. Let's go over here to JavaScript. So it's going to have to execute because we've changed our config. And in just a second, we're going to see what some of the violations are. We'll go ahead and go over here and we can see when they get added. Yeah. So we'll go down here. It's our same line 64, line 64. We're going to have a couple of options. One of them is going to be the IDE zone convert to let, but we're going to use fix for Agentforce for developers. This is another example. I think this one happens pretty quickly. This one did the right thing. I've seen it do the right thing sometimes. I've seen it do the right thing here and then actually come down here and change this regex here and take out the escaping here and change it into a comment, and it broke that. So it was a partially successful, partial failure. Again, Control Z and it will back you out. So you don't need to worry about that. You can actually get back out of this very easily and not have to worry about that. All right, let's look at one more example. Let's go over here to the flow file. We're kind of going back through the same things. So it's re-executing here. As soon as it gets done, we'll take a look and we'll use fix with Agentforce for developers. Now, we'll see if it does the same thing it did before. So this time it did the right thing because it says that it wants it to be higher than 54. So this is going to come back. It's going to clear that. We're still going to have the Illuminated Cloud inconsistent API violation. On my previous iteration, just to show how this is non-deterministic, it changed it to 54. It says less than or equal to 54, but it changed it to 54, and on the next one it changed it to 58. So again, just be careful, okay? Be careful with what you get. But it is a very cool mechanism, and when it works very nicely. I've actually added it for what it's worth because I find it to be useful enough. If I say ignore redundant rules, and I go over here, of course it's going to reevaluate. We're going to drop these Salesforce Code Analyzer ones, and let's go to this one. And let's go ahead and let's see, we want a PMD one actually. Let's go back up here and let's back out this. And now PMD in real time. So this is unsaved. So we see the little dot up here, it's unsaved, but PMD is reporting that this is an injection vulnerability. I've actually added the fix with Agentforce for Developers quick fix to PMD's set of quick fixes because it should do effectively the same thing, and PMD itself doesn't come with quick fixes. So I've actually used that to add prospective quick fixes to PMD. So there you can see that for the real-time PMD inspection, you still have that ability. Okay, so I've rambled on for a really long time. I hope you find this useful. This just adds to the full palette of static code analysis capabilities in Illuminated Cloud. And as Salesforce Code Analyzer continues to add more engines, integrate more engines, it'll just add to that same kind of palette, that toolkit. I hope that I've made it clear the value of ignore redundant rules, but it is important that you make sure that Salesforce Code Analyzer and the first class corresponding static code analyzer in the IDE are configured similarly or identically. In the case of PMD, they use the same rule set. In the case of ESLint, they use the same ESLint RC configuration files. In the case of CPD versus the duplicate code detector, they use similar enough thresholds. Basically, both of them have a threshold of the number of repeated tokens that constitute duplicate code. Because if they're not, you're not going to necessarily be dealing with redundancy. I think I've shown that for Salesforce Code Analyzer, you need to have persisted to disk before it's going to make sense to run the code analyzer, and the various configuration options. If you find any issues, let me know. If you find bugs that are clearly this integration, let me know. If you have ideas for improvement, let me know. Otherwise, thank you very much for spending so much time with me, and take care.